Before I start the video, I would like to say thanks to Beckhoff Japan and Manda Design Works. The device that using in this video, for example, the Beckhoff IPC C6920 is borrowed from Beckhoff Japan, and the Siemens Drive S210 is borrowed from Manda Design Works. I really want to say thanks to you. Because of your support, I can make more videos and tutorials to share our information. Thanks.
Hey Evan, I'm Brice. Now is part 3 of our TwinCAT and Siemens Drive operation video. In this video, I will show you how to use PLCOPEN Library, for example, MC Open, MC Power, MC Reset, or MC Joke, or some standard function block to operate the Siemens Servo Drive S210 with TwinCAT. I hope you like this video. Let's start. Okay, here is the correlation in this video. It's not so different between last video and this time. And here is the Beckhoff PLC, and here the Siemens safety PLC, and they are always connecting its spoofing net with a S200 Siemens Servo Drive, and here is the servo motor. Let's start the programming. Okay, now is the time for programming the TwinCAT and control our Siemens Servo Drive. The first thing, you need to insert the library from TwinCAT. There's the two libraries in here you need to use. The first one is tc2_mc2. The second one is tc2_mc2_drive. Please don't forget to insert this library in your project. The second thing, actually we need to define a access object in our project. Don't worry, I will have a very detailed text version in my blog, maybe release after 1 week or something, a few days. In here I just show you what's the fast way to run the drive and make some commands to operate the drive. Okay, so here is your main POUs. So here's some old program I created before, just delete it. The first thing I will define a access object. So my access and access reference. Here is the access object that you need to link to the motion object in here. The NC task in here is so many access here, right? You need to link this object to the access object. So first thing, I will build my project. Make sure no error in here. Okay, no error. Good. And the second thing, I will open the motion and go to access, and access 1, go to settings. In the last tutorial, we linked, I think the first part tutorial, we linked the spoofing net IO drive, the telegram, to the IO field. Now we need to link the PLC, the drive object, to the PLC variables. Just click it. Then you will see that the access that we defined before, the main.access. Click it and OK. Done. Now the object, now you configure everything. You can do your programming now. Okay, just close it and open our project again. Okay, first thing, I need to define some MC object, MC function block for us to operate the S210. I will define one more variable field in here. The first thing, I need to reset my drive. NC reset. Here is MC reset. LESET. Good. Okay, the second one is MC power. It's a function block to turn on your drive. You need to use it before you make any job. You need to enable your drive first. MC power. Okay, so and then I'll define one more field. It's just for these function blocks parameters. The first one I will use define B power on. Okay, and the second one I will define the B reset. It's used to reset. Okay, done. So we reset our drivers. So MC reset, and when you call this function block, you need to assign some parameter. Actually, the main one you need to assign the axis. So axis is equal to axis, and execute is equal to b reset. Done. The next one is need to call the MC power function block. Axis is equal to axis, and enable is equal to enable. B enable, B power 1, right? And here some actual option that you need to do. For example, first say enable positive as a parameter to choose your drive can rotate in the positive direction or not. Actually true, right? And other same as is a other position option called enable negative. Just make this to true also. And finally there's a parameter called override. The how many percent, for example, if your override setting is as 50%, although does that mean that although your speed command is 100%, then finally the output will be 50%. Makes sense, right? Okay, done. So I reset my drive first, and then I call my MC function block, MC power on, turn on my drive. Then in this drive is I can enable in the positive rotations and negative rotation as a 100% override. Good. So let's save our project, activate direct conversions to download the conversion to our runtime, and reset to run mode. Just wait a second. Okay, done. And here we can log in to download our project. Yes. Okay, and play it. Good. But the first thing we need to do is we need to go back to Siemens project, open our TIA project here. Now, as you see here, the safety output is false. In this tutorial, we still didn't have any data exchange between TwinCAT and Siemens directly, because we're only using shared device to allow two controllers to access one drive, right? But don't worry, in next tutorial, I will just there's some 10 minutes work to show you how to connect the make some data exchange between Siemens and TwinCAT. There's so many options. Yes, sure. Okay, here I just want to reset here. Good, reset. Good. Now you see the eStop.q is turned to true, and safety fault active is false, and S2 is not turning on. Now it seems like the drive is ready. Okay, here the first thing we need to reset our drive, and then now we can turn on our drive. Okay, open the MC power function block. You can see that there's so many parameters here, right? And just turn it on. Done. Now you see this busy and active, and say that it's true, and also no error ID. Now means your drive is ready to operate. Done. So after you turn on our drive, the first thing I need to check the joke operations. Joke operations is very important that before you run it as some absolute positioning job or relative positioning job, the first thing you need to make sure the servo motor can run in joke mode without any error, doesn't crash anything. So MC joke, and MC joke. Done. And here just B forward, B backward. But don't worry, in the text version, the tutorial, I write more information about which function block, how to work, and make it a little bit more clear. So don't worry here. I just show you how the fast way how to run the drive. It's boot type, right? And we need the speed. R32 joke speed. R is a 64-bit variables. Done. Okay, so in here, just make more space, NZ joke, and go here, call the MC joke function block, axis equal to axis, and next one is joke forward is equal to B forward, and log B backward. Okay, then B joke joke backward is equal to B backward B backward and not B forward. Done. And finally we to use the velocity is equal to R2 joke speed. Okay, done. Save it and log in again. Good, it seems like it works. So go to forward. Let's choose forward. Oh no, before we need to set the speed. Just give a default value to him. Okay, log in again. Okay, and because it's just a default value, so we change one more time here. And I will forward it. Let's see the camera. I hope my camera is work. Oh, just me a second. Okay, sorry. I adjust my camera now. It seems to work. Oh, sorry. Yes, now it's joking forward, right? Just stop it, and now choke it in backward. Open the camera again. You see now it's joking backward. Right. Very good. And now we can try to read the actual position and actual speed from our drive. And you need also can directly read from here, but I don't like to do that. I like to use the function block to just read what kind of information I would like to read. So go here and I forgot the name. Is MC for what? MC read actual position. Okay, actual position. And just copy this function block name. And here again. Okay. Then MC read actual. What is that? MC read actual velocity. Good. And just copy it and make some space, make it more easy. Okay. Now we can call the function block. It's just a function block to read actual position and actual speed. So call it MC read actual position. Same pass the axis equal to axis and enable in here is just a true, but actually maybe you need to make some connection. For example, the communication between PLCOPEN between the drive and TwinCAT is okay something. And position is equal to actual position, right? That I will LSIDON and speed BEOLOCITY is also a read type. Done. And position is equal to position and MC read actual velocity, same, actual is equal to axis and enable is equal to true. And also you need to add the communication status between the PLCOPEN in the real applications. And velocity actual velocity is equal to VEO. Okay, done. Yeah, it's because it's output, so it's that one. That log in again, down the project again. Then you see some value. It's here. Now when we try to turn on our drive again, you see the value is changing. Actually the drive also running. Good. Okay. So in here, the next one I will show you how to execute a absolute positioning and relative positioning. So absolute positioning, you can imagine it. Imagine it is just a positioning job that to go exactly what you want to go. For example, I want to go 500 mm, that the drive will exactly go to 500 mm. 500 mm. So for example, by the way, if you're using relative positioning, it means it will depend on your current position, then you plus or minus the distance. For example, your distance is now 100. If you use relative positioning, your distance is 200. So you after execute the function block without any error, actually your distance now will be 100 plus 200 will be equal to 300, and the second time will be 500 and 700 something. And also you can plus the minus command, set point, to let the drive to run in the other directions. For example, you pass a minus 200 mm to your drive to execute this function. The next, after execute the function block, your actual position will be 700 minus 200. It will be 500 mm. Just like this. So MC absolutely move. What's that? REV. I forgot the name. Move. Move absolute. Yeah, sorry. MC REL is MC move. REV. Good. And just paste the same name here. Okay, done. And here B REV, B yellow, B ABS is blue. Is available for trigger the job. And then B R32 relative speed and R32 relative pose is a view, right? R32, okay, 64, but yeah, same. ABS speed, R32 ABS pose. Okay, same. Good. Now you configure all this one. Now just call the function block. MC move absolute for the absolute positioning. Axis equal to axis. Execute is equal execute is equal to B ABS, yes, and position is equal to R32 ABS pose, and speed is equal to R32 ABS speed. Okay, done. Let's do the same thing for the relative positioning. Move REL, yes, let's go relative. Axis is equal to axis. Execute is equal to B REVL, and distance is equal to R32 view position, yes, and speed V is equal to R32 view speed. Right, done. Good. Right, just log in the program again. Good, and just set the actual position to 0. Now it's okay. Just change the speed and change the speed. Okay, now you see the actual position is around 2700 something. Right here you can see here, also you can see here. Then I will trigger the absolute positioning. Let's see. Okay, trigger it. Then you see now it's back working, and here's camera. Oh, then you see my camera here. It's also okay. Sorry, I triggered 1000 again. Then you see again. Okay, and this bit is a positive gauge, so we need to turn it off again and turn it on. Okay, now see the drive is running in positive directions, and now the position is 1000. So the next one is I will trigger the relative positioning. So how to do it? Just go to here to set the speed is a bit slow, and for example I will change, for example, minus 200. Okay, so the current speed is 1000. If I trigger the relative positioning task, then what is the final position of the function point execute? It should be 1000 minus 200 is 800. Okay, let's see, is this true or not? Let's trigger it. You see now, oh, now the drive is running here. Let's try again, sorry. But actually you see now it's 800. So if I trigger again, it should be 600. Let's do it. Check my camera position is okay or not. Good. Trigger it. See now it's, oh, sorry. Just trigger net the position to meet bit. Now maybe it should be minus 200, right? Just trigger this drop again and check my camera position. Okay, good. And trigger it. This drive is running in the other directions, and the current position is minus 200. Done. So now if I change the position to 800 and I trigger the relative again, you see the position now is changed to 800. See? So finally I use the S210 again. Now change the position to 0. It should be jump back to 0. Let's see. Let's change, need to be slow. Okay. Now it's running, and you see the servo motor now it's running here. Good. Okay. So you see now all the functions done. And finally, I'll show you one more function block. Is read the current status of your drive, because I feel very like TwinCAT that provide this type of function block, so no need to do yourself so much. So MC read actual read access status. I think is actual access status. Actual status. Yes. And one more is read the error. MC read error. I think it's read error. I saw of the MC read access error. So good. And here just call it again. Read status. And access equal to access. Enable is equal to true. And here's status. I will use this one. It's a structured data type. status is equal to. I'll define one more in here, and it is status. st underscore access status. Access status. Yes, the US. Good. And other way, I'll call the MC read error. Yeah. And access equal to access again, and enable equal to true. Good. And down again. Good. Just 1 second. Okay. Now let's see what the block is running here. MC read status. Now good, you can see now the access enable, BC, no error, standstill, and not stopping, no error stop, not disable, and power. Yeah, and here's status. If you open this, you see more information here. What's the cycle counter, and what same standard operations, and it's operable in here. What's that? There's so many information you can see here, so useful. And here's read error again. Now it sees no error in here. Good. So And finally, I will trigger the STO to see while I'm running the motion task, is the STO the trigger or not. Check the camera. Okay, here you see a e-stop in here, right? I will pass this e-stop. Just wait a second, okay? Just make a now the current position is 0, okay, right? I will the position to 2000, just make it a little bit long. Okay, let's reset the speed. Okay, now in here you see the motor is running, right? I'll turn the e-stop. Okay, now the drive is turned off. The STO is active. When checking the Siemens project, the STO is active, the e-stop is in force, and we check the status. The read error now is okay, no error because it's not for this one. And here it's a read status, open status, then disable is turning on. So because the STO is triggered, and also you see now it's not operatable in here, false because not ready, and not moving because now stop, right? And yes, so many information you can check by yourself in here. I will not explain too much. Okay, so in this tutorial I will stop in here. I hope you understand what I talk here, and if you have any questions, please comment and please like my video. Your like is push me to do more and more. Okay, thanks. And the next part, in the next tutorial, I think it's 1 week after something, I will show you how to connect, how to exchange some data between Siemens and TwinCAT. It's just a 10-minute something video. Let's see you in the next video. Thanks for watching my video, and I hope to see you again. Bye bye.